Hello and welcome back to the lab. Today on the bench we have another piece of Tektronix curve tracer. I don't want to say oddware, but just an absolutely massive front porch for the 576 curve tracers. This one is when I talk about power bands in the curve tracers, so the 576 being for high-powered devices, where the 577 is geared more towards small signal devices. That is proven out in their auxiliary front porches. Here are the two front porches for the 577 and the 578. The 577 is for testing ICs, op amps, things like that. 576, or the 178, is for testing ICs, op amps, things like that, and it's on the 577. The 178 is a high current test fixture, and it's for the 576. So the power bands of the two curve tracers, they both overlap quite a bit, but the 576 is geared for high power devices. The 577 is geared for small signal devices, op amps, transistors, things like that. Which is also a little strange because the 577 gives you 100 more volts on the collector. So that's a little odd too. But today on the bench, we've taken a look at this one shortly. I'm still looking for some pieces for it. I need a fixture for up top and some adapter boards. I do want to get this working. I have some 577s this could park in. But for right now, we're going to take a look at the 176. So this particular unit, I haven't even plugged it into a frame yet. It says library. Wonder where you could check one of these out these days. But needs a little bit of cleanup. It's got some crud on it. This was actually some battle damage from shipping. Not a fan of that. The contacts look like this thing has been well used. This has not been sat on a shelf. So I want to get in here and I want to, you can see, let me zoom in on those real quick. On the contacts, there's mating and unmating on the surfaces, so those have been well used. Overall, it's in good condition. I wouldn't consider it bad by any stretch of the imagination. A little bit of battle damage from shipping, but at least all the screws are there. Everything's good. So I took a peek at the calibration document for this one. There is not much to calibrate on these. So it's essentially going to be some validation, some testing. I'm going to clean these jacks real good so we get some good connections. Although when you're dumping 200 amps through something, I'm not sure how much a good connection matters. It does, but this is pulsing a lot of current. Yeah, this will do up to 300 volts. It will do 1,000 watts into a power transistor. So we have a pretty decent amount of current available to us with this test fixture. So let me get some cleaning done, and we'll get this all cleaned up. Then we'll get it hooked up and see what it does. Okay, I've got all the screws taken out. Everything is ready to go. So I've taken the two panels off. They're up here. And let's see what we have inside. Oh. Wow. All right, so there's a lot going on here, actually. Yeah, some of these relays are... Glad I opened it up before I turned it on. Some of those relays were not seated properly. Looking around for adjustments, and I'm not seeing any on this particular example. Let's see. Oh, yep, there's the one. That's the centering control right there. That's the one adjustment that's in here. So we'll see if it even needs an adjustment, and we'll go from there. But there's a fan. Still turns pretty good. Doesn't look too crusty. Actually, that bearing in that fan is turning very nicely. And the fan is not crusty. So, that's okay. Got some power transistors over here, heat sinked. Those will be fun. But I think some cool stuff is going to be, yeah, there we go. Look at these parallel capacitor banks with a diode across them, and then the massive coils. I don't know if you can see through there. Get a light. Back in there, there are some absolutely just monstrous coils back there hiding behind those capacitors. That's pretty crazy. Let's see. I'm not seeing anything burnt, blackened, grenaded, blown up. So there's another row of coils. There's a bunch of smaller coils, probably for the lower ranges. Another capacitor bank over here. Lots of caps in here. Holy cow. Oh, recapping this thing would be a nightmare. Hopefully we don't have to get into that. Big precision resistors next to these relays. Those guys are huge. Everything in here is huge. This thing is just supersized. I mean, look at the cables coming off of here. Just monstrous. Okay, that makes more sense. I was trying to figure out. You tell it what you want the max peak power to be, and this chart tells you what the series resistance is. So like on the 15 volt rail, if you select 1,000 watts, you get 61 milliohms of resistance through the test fixture, or the series resistor is 61 milliohms. Just gonna see if these sockets need a bit of cleaning. Yeah, there's some stuff coming out of them. Somebody's bypassed the interlock on this unit. I'm not sure how safe that is. They've put a little wire to close the lid. I mean, if you're dumping 1,000 watts through a transistor and it decides to go, depending on the size of the transistor, it could go in a big way. There we go. That cleaned it up a little bit. It was kind of grody. I did find a cal sticker on it. It's due up for cal in 04. So let me get the side panels put back on, or let me get the panels put back on, and we'll see if we can give it a turn on. If it does anything. I hope it doesn't take out my 576. That's a good thing we inspected before we powered it up. This relay that was kind of cattywampus. I'm going to pull it out. The keeper bar was shorted out underneath the relay. Give a quick visual on these contacts, make sure they look good. These look okay. Get a pair of pliers. That's not going down far enough for my liking. No, that's okay. It's not supposed to be in the further down hole. It's supposed to be in the top one. Actually, let me check these other relays here while I'm at it. These all look okay. Yeah, those all look alright. Everything looks good. Fan's clear. So we're going to try powering this thing up here in a second. And since we're playing with high current, I do not want to short this out. Alright, let me get the bottom put back on. Be right back. Okay, to put the front porch in, the unit's off. These come out. This pops out. This absolute ginormous box pops in. And sits on the front. Now, to operate the test fixture, 300 microseconds, pulses need to be set. Now, step generator, gonna give it a bit. 0 this, number of steps 1 is fine. Vertical, give it about an amp per division. 0, 10, 1 volt. 15 is okay. Alright, I have my, it's not on the current limited supply, but I do have it current monitoring, so if anything goes catastrophically wrong, we'll watch it. Drawing about an amp, 90 watts. Powered up, fan sounds good. That's a nice, quiet, that's not bad at all. Alright. We're settling down about 80 watts on the 576, so that's healthy. Let's see if we have some life. Yep, I got a spot where it should be. Alright, let me go get a shorting bar. Here's a nice chunk of copper. We can put some current through that, and let's see if we can measure something. Okay, as we can see, I have a nice 14 gauge copper resistor in here. We don't have a warning light, so everything looks good. See what happens. Hey, look. Very cool. Turn down the horizontal to 0.1. And we'll and there's the spot, so it's measuring current. Give it some more power. Oh yeah, much sooner on the dial. Yep. Well, it seems to be working. Turn that down to 2 amps. I can actually hear the coils buzzing in there a little bit. That was at 100 watts. So if I brighten this up so it makes it easier for everybody to see it. If the readings are right, 2 amps, 4 amps, 5 amps, 6 amps, oh no, that's even more. 2, 4, 6, 8, 10 amps going through that wire. So I think it's working. Well, I know the curve tracer's calibrated, so should be good. Everything's behaving healthy, things like that. I have a cal document. I have the appropriate load resistor on the way to test this out. So when that comes in, we'll go through that. We'll test it out, and if everything works, we will have a functioning high current fixture here in the lab. Perfect. Okay, there is a lot going on here, and I was arguing with this for a while, thinking about it, trying to figure out what was going on. I was going to go through a validation of the 176. However, I picked up a standard load resistor. This is turned all the way down, by the way. And I was hoping to do just a validation and check-in of the 176. Of course, ran into problems, but it's not what I thought. So problem number 1, there is a way to bypass these interlocks. I do not show this on camera specifically. Bypassing the interlocks on these is very dangerous. I'm very comfortable working around high voltage. I've been doing it for quite some time. So there are ways to bypass the interlocks. If you bypass the interlock, you do so at your own risk. This can source 1,000 watts at 350 volts. It is nothing to mess with. The curve tracer by itself can source 1,500 volts. It is nothing to mess with. So bypass the interlocks at your own risk. I also don't show that on camera because if you need assistance bypassing the interlock, enough said. This is not the way to bypass the interlock. I'm going to zoom in on this. This wire was crammed into this hole. There's a lid switch right here for a plastic enclosure to turn the curve tracer on. That wire came all the way out of that hole. I thought it was a little stub of wire about yay big, not very long. That whole thing pulled out from inside here. That is not the way to bypass an interlock. That could have shorted out. That could have done all kinds of stuff. That could have screwed with this thing. Not the way to do that. So don't do it that way. The other thing that I ran into was, so I bought the load resistors, figured, hey, you know, they're load resistors, they should be good. Their tolerance is 0.5% at 4 watts. So these are some pretty stout resistors in here. And we'll get into that in a second because I had it set up to do the first test, and I just wanted to validate the standard resistors and figure out, you know, everything's working, is it not working, what's going on. And the thing went out to lunch. It wouldn't work for me, couldn't get anything to line up, couldn't find the trace on the monitor, just completely out to lunch. And so I'm scratching my head going, what's going on here? Well, if I turn this up, this is in the wrong position for this test. So this is not the correct setup for the first test of the 176 check-in, but I'll get to that in a minute. What I was supposed to do, if we take a look at the display, if I wind up the current here, there we go, there's the trace. As it intersects the top line, I should be plus or minus 2 divisions from the top line. No big deal. This is correct, except for the fact that I'm using the 2 amp per division resistor as opposed to the 0.2 amp per division resistor. move over to the 6500 and I'll show you what's going on. So it turns out the way these load resistors work is you have collector and base loads on the test terminals. So when you have the shorting bar in this position, you're supposed to put it's supposed to put a 0.25 ohm load across the collector. And this is also done in 4-wire sensing, so we're dealing with some very small resistance, but we're dealing with an incredibly high wattage. Makes sense. The bottom position is supposed to put a 0.0025 ohm resistor across the collector and emitter terminals of the 176. On the other side, it's base loads. So we have a 0.1 and a 0.5 resistor on the base step gen for the same thing. Put the shorting bar over here, I get 0.5 ohms. Put the shorting bar here, I get 0.1 ohms. Well, I'll put the shorting bar here, which is supposed to be 0.025. And I'm going to go collector to emitter, so we have collector and emitter. And because we're measuring such an incredibly low resistance, we're going to use 4-wire probes. Meter set up to 4-wire. 0.049. Not even close to 0.025. Almost double. So that's why I couldn't find it. The resistors in the load are bad. Now, why was the test there before? Because this is supposed to be 0.025. So if we hook this up, we do 4-wire measurement again. 0.024. So this load resistor is off by an order of magnitude. I should have an extra decimal place here. So the load box is bad. So what that tells me from at least the rudimentary tests that I can do is the 176 is measuring exactly as it's supposed to, because it showed me correctly what it should when I had the correct resistance, but not when I was off by a lot. So at the moment, this is the best I can do in the lab. I don't have any incredibly low value, high wattage resistors. I'm going to have to order some, which I'm not looking forward to. Those are probably going to be expensive. But we'll have to rebuild this resistance box. I'll get the guys on talk to some people and figure out what I got to do. But all the resistors in here are bad. The base ones are as well. So I'm not 100% sure where this was stored. But if I do base to emitter, that should be 0.5. We're at 0.6, and bear in mind these are 0.5% resistors, so these are precision resistors. This is 0.1, which is almost 1. So that should be, yeah, that should be 0.1. So that's off by 10% as well. So I don't know if these resistors have been abused, if they've soaked up some water. Let's see, this comes off this way. No. Only one side comes off. If you're holding it this way, if you're holding it right side up, the right side comes off. These are Tektronix. These are actually Tektronix brand, but there's they're high power resistors, but their values drifted over time, so can't use those as expected. But the good news is that actually proves out, at least as best as I can test it at the moment, the 176. So looks like it is working, and everything is ready to go. If anybody can think of some other tests I can do on it to check it before I rebuild this resistor pack, let me know, and we'll run some tests on it. But that's unfortunately going to have to be a stopping point for me, because this was supposed to let me finish it up, but can't do that with wrong values. Thanks for stopping by the lab, taking a look at the 176 pulsed high current fixture. Given the fact that we can test up to 350 volts and 1,000 watts, let me know in the comments if there's anything you'd like to see me put across the test terminals. I have some high current 3-terminal and 2-terminal devices that I'll end up needing to be testing with this. Do need to figure out another way to confirm the accuracy, but it looks pretty good for now. And the accuracy of this is only about 15%. The curve tracer I know is good because I have the cal fixture for that, and that's already in cal. So I just need to check the fixture, but as you just saw, my load resistors are kind of toast. So let me know if you guys have any suggestions for videos in the comments. I do read all the comments, and I will see everybody in the next video. Bye for now.